Hi, I'm Andrew, and this is part 14 in my Advent of Code series, where every day I'm attempting to solve a new code challenge. Previous videos are on a playlist on my channel called Advent of Code 2022, and for any day if I'm able to solve the challenge, any code that I write will be uploaded to my public repo, and the link for that is in the description of this video. For today, let's get started with part 14. We have a distress signal that leads you to a giant waterfall. Actually, hang on, the signal seems like it's coming from the waterfall itself, and that doesn't make any sense. However, you do notice a little path that leads behind the waterfall. The distress signal leads you behind the giant waterfall, and there's a large cave system here. And as you make your way deeper underground, you feel the ground rumble for a moment. Sand begins pouring into the cave. We need to figure out where the sand is going so we can or else we'll quickly become trapped. Fortunately, our familiarity with analyzing the path of falling material will come in handy here. We scan a two-dimensional vertical slice of the cave above you, which is our puzzle input, and discover that it is mostly air with structures made of rock. We scan the path of each solid rock structure, and it reports x and y coordinates that form the shape of the path. X represents distance to the right and y represents distance down. Each path appears as a single line of text in your scan. After the first point of each path, each point indicates the end of the straight horizontal or vertical line to be drawn from the previous point. So for example, these would be our scan. This means that there are two paths of rock. The first path is two straight lines. Okay, so the line is going to be between these points. So we have two lines here and three lines here. The sand is pouring into the cave from point 500, drawing rock as $, air as a period, and the source of sand is a plus. This is what our grid looks like. Okay, so we start at the top, and we start at 0 going down, and then these are reference points, so 494 must be the furthest left that we have, and that's here. So our rock, this is our first rock line, so it starts here, goes over, and then goes up. Here it comes over, down, and then over, so this is where the sand starts falling down. Sand is produced one unit at a time, and the next unit of sand is not produced until the previous unit of sand comes to rest. A unit of sand is large enough to fill one tile of air in your scan. Okay, so that would be just one square. A unit of sand always falls down one step if possible. If the tile immediately below is blocked by rock or sand, the unit of sand attempts to instead move diagonally one step down and to the left. If that tile is blocked, the unit of sand attempts to instead move diagonally one step down and to the right. Sand keeps moving as long as it is able to do so, and each step trying to move down, then left, then right. If all three possible destinations are blocked, the unit of sand comes to rest and no longer moves, at which point the next unit of sand is created back at the source. Okay, so this one would come down. Oh, here it shows an example. Drawing sand that has come to rest as an O. This one falls straight down. The next one would fall down and hit this one and then move down to the left. After a total of 5 units have come to rest. So the next one would hit this one and go to the right. The next one would hit and it wouldn't be able to go to either of them, so it should stay there. Yep. And then we get one down here, so this next one would come down, it would hit this one, it would come down to the left. But it wouldn't stop, it would keep trying to go down until it can't anymore. So here it could go down to the left, but then it's blocked. Okay, so after a total of 22 units of sand, it would continue filling up like this, and then only 2 more units of sand could possibly come to rest. That's because they come here and then comes off the edge here and then falls down. Once all 24 units of sand shown above come to rest. All further sand flows out the bottom, falling into the endless void. Um, okay. Oh, so it looks like it, yeah. When the sand falls, it just keeps going, and then the edge of our map shows one more over because that's where the sand falls off. So using our scan, we need to simulate the falling sand and find how many units of sand come to rest before sand starts flowing into the abyss below. Okay, so the conditions, I think we can simulate this okay. The first thing we'll need to do is just kind of map out something like this where we draw our lines of the rock to get a starting point of which spaces are taken, and then from there it shouldn't really matter whether it's rock or sand that's taking up the space. We can just simulate each falling point, but in order to know if it didn't come to rest, I think we need to know if we're going maybe too far off to the left or right. Yeah, okay. So let's get started with our puzzle input, and we've got quite a lot of lines to draw. Okay. We'll probably just want to start with the example input for this one. All right, so we'll start here, and then for day 14, first thing we'll need to do is start parsing these. So this is a X and Y location, it looks like. So then the next one, we need to draw a line from here to there. So for each of these, we'll just need to create a list of points and then add a calculation to fill in all the points in between. So we can split by this section where it's a space and then the arrow. That'll just give us our number, our coordinates. So we'll say probably make a coordinate class. And that will have an X and a Y. Yeah, and then we'll want to make something to create this from a string. So we'll say our companion object has a function of from, that'll be a string. So then we'll take our input and we'll want to say each rock line will be one of these. So each rock line will be a list of points, where each point is sort of like a point where we turn. So we'll say rock lines is a list of coordinates. So we'll do that, and then we'll take our input and we'll just say take this. We might be able to just map this instead of doing a for each, because for each of our lines like this, we will just be taking it, splitting by our delimiter, and what that'll do is leave us with a list of these pairs, and we can take that string directly and put it into our function, and then that can handle splitting out the commas. So like this, we would say return a coordinate where x equals string split comma the first to integer, and then the y should be the a second point, like this. And we'll see what the problem here is. It needs a return like that. Okay. Yeah, so far so good. So for each of these, um, we would need to add into our rock lines. So in order to just map this, um, I think we could take our input map. So now we're gonna have a list of something, and we will take um, we'll take our line like this. I think get rid of our for each. Um, yep, something like this, and then line split. We'll map that into coordinate from it. So that should give us rock lines as a list of coordinates. And then we're going to need to create our grid, which will be a 2D array, similar to what it showed in the challenge description. So just create that. So it'll be a mutable list of mutable lists of a grid is going to have, let's see, multiple points. We'll probably want something to represent the coordinates, and well, the coordinates will be the x, y of the 2D array, but I think we might just need a Boolean to say whether it's filled or not. So we'll probably just do that. I don't think we need to know anything else about each space. So for something here, we would go, in order to build out our grid, we're going to need to know how high, like in this case, it's only as wide as the rock lines show. And it's only as tall, it's going to start at 0, so then the bottom of the rock line is at 9, so that kind of constrains. I think we could probably do something similar. Um, and I wonder if the sand always starts falling at 500. I don't know if it said that. Um, yeah, so I think that'll always be the same. All right. For now, let's just try to represent this. And I think the next thing we need to do first is populate all of the rock lines in between our points, because in our input we just have these so far, but we need to fill in between each point every rock coordinate. So we have our list with those points, so let's make a function to fill in between, and we can make that an extension function on list of coordinate. And we can say fill rock lines. This will return a list of coordinates. And what we'll do is we will take um, each pair of items. So we'll say windowed 2, and that'll take like this pair of coordinates and then this pair of coordinates and so on, and fill in each item between them. So yeah, let's start with that. Um, we'll take this, say for each, and we'll make a list to fill in like this. All right, and then we'll return that at the end. Okay, so now we'll start with um, rock lines. We need to figure out, I guess, if we're going up, down, left, or right. And so we can take our from and to is going to be the first and second. Um, yeah, because it can draw really any way. So we will say this will be a destructured declaration, and we'll say start and end this. And in order to figure out which way we're going, we'll say if start x is the same as end x, we're moving vertically. Else if start y equals end y, then we are moving horizontally, right? So in this case, the x is the same for each of these. We're just moving from 4 to 6, and this is from top to bottom, so we would be moving from 4 down to 6. Um, yeah, so we just need to add every value in between. Um, so for that, when we're moving vertically, we'll say if start y is greater than end y, then we will add um, we will take every item between start y and end y. If we take repeat, we'll take start y minus end y. Otherwise, we'll take end y minus start y. Like this. So we should always have a positive number, and we will take our rock lines and add the point in between. And in this case, we are moving up, otherwise we're moving down. And then we'll want to copy the same logic down for horizontally, where um, we're going to be checking the x instead. And in this case, if start x is greater than end x, then we are moving left, otherwise we're moving right. Great. And what we're doing for each of these is um, we're going to add a coordinate um, where x stays the same. So it'll be, we can just keep the start x, and then y is going to be start y, and if we're moving up, then it's going to be minus our repeat, our iteration count. because for each value, if we're at 9 down and we need to go up to 6, then we would have 3 that we go up. So for each of those, we would go up to each of those values. So let's copy this over for each other one. Here it would be plus, and it'll be the same thing for these. But it will be the reverse, where we keep the start y and we change the x. Okay. And here we'll add. So now let's run this as part of our calculating the rock lines. And we will say like that. So now for each line, instead of just having these 3 values, we should have every value in between as well. So let's debug that and make sure. And I need to change this to day 14. And let's run it. Okay, so we ran it without crashing. Now let's check our rock lines. Let's see what we got. So for here, it says there's 4 points. And so we should have 498.4, 498.5, and 498.6. We do. And then we should also have, for this section, we should have 497.6, and we should have 496.6. So we're missing that last item. We've got the first one, but we need the last one. So we should include the end. Because there's 4 points, and I think in the map it showed 5, right? And it's probably going to be the same thing here, where we don't include the last value, which was 494.9. And yeah, so we have 496, 495, but not 494. So we're just missing one thing. Let's add that in under here. So filling the rock lines, we'll need to take this, and for each of our windowed, we can, well, so far it seems like we're only missing the very last item, because we're always getting the first one. I think I can try to just take our last one when we start, but there's a risk that something might not work right with our full sample input, so I'm going to add. I'm always going to add the first and end to our list for the windowed, and then we'll just distinct it at the end, just to reduce the chance that we miss one along the way. These don't have to be in order, so we could just go like that, and then we'll return rock lines distinct. So now if we debug again, we should be able to see more items. There are rock lines, now we have 5 and 15, which is correct. If we look here, we have 498.4, and down here, finally, we have 496.6. So they're out of order, but that's okay, because when we go through these, we're just going to use them to mark on our grid of what is already filled in. All right, so now we're ready to start filling in the grid, and one thing to point out that we're going to need to handle is building out this grid. The leftmost point that we have rock location for is 494, but really in our lists, this is going to be index 0, so we need to figure out the offset by getting the leftmost coordinate for x and the rightmost, and then we only need to fill lists for whatever our bottom item is. So we have our list of all rock points. We'll want to get those values to see how big of our lists we should make. So let's go ahead and do that. Because when we create these for the grid, we can actually create them just with a fixed number. For our rock lines, we will want to figure that out. We can make a function for getting the left, right, and bottom. Get edge locations, and that will return that can return a list of integers, which will be left, right, and bottom. And we'll make that off of a list of coordinates. And we'll just get those values here. So destructuring it, we can say left, right, and bottom is equal to our rock lines. Flat map, or just flatten, and then get edge locations. And we'll need that to happen up here before we create our grid. So the logic for that will be taking a list of coordinates and finding the min by it x. So the smallest value of x will be our left. Right will be max by x, and then bottom will be max by y. And we know that it can't ever go above 0. At least I don't think it can. We'll see. So for these, that's what we'll return. And then we'll just print that off. We should have, we found coordinates. And that's what each of these are. That's what we'll convert them to, the x and y. So there we go. Now when we get those values, we should be able to see what they represent. And in our sample, the leftmost point should be 496. Or is it 494? Yeah, 494, because this rock formation, which is from this one, this goes down and all the way to 494. The rightmost should be 503, and the bottom should be 9, which looks correct. So when we're creating our grid, we just need to make sure that the width is the right minus the left. Okay, so that would put us to 9 wide by 9 tall. I think that's correct. So we would have 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, because it's inclusive. And we need to get the offset as well so that our indexes can start at 0. So left offset will be our left, and I guess that doesn't even matter because we already have left here. So now when we create our 2D array for the grid, we can create them with that number of elements. And we don't have to make it a mutable list of lists. We can just make it a list of mutable booleans. Like that. When we create this, it should be the size of our first list is going to be our right minus our left. and initializing it, it will be a mutable list. So then we will also do it with a fixed size. Like this, and the size will be this one should be right to left, and the first one should be our bottom, like that. Okay. And when we initialize these, they will all start out as false. Okay. So now let's run our grid and see how it looks. Okay, our grid is a list of 9 by 9, and I think it needs to be actually 10 by 10. That's what it showed here. Yeah, 0 through 9. So I think we just need to add 1 to each of these. 1, 2, 3, 4, 5, 6. Yep. Okay, so we will add 1 to these. So then we're ready to fill in the grid with our rock line. Yeah, for which squares are filled. So we can take this, we can even flatten it, and then we can go ahead and for each coordinate, we'll just go in our grid and mark that as true. So rock lines for each. Grid, we'll say rock is here. Grid, rock Y by an X of rock X is going to be true. So by the time we're done with this, we should be able to see that only those coordinates are marked as true. And we got an out of bounds, so index 498, and that's because we need to normalize them where we subtract the left from these. So for anytime we get x, we should take it minus our left. Okay, we'll debug again. So now here, our grid, we do have a 10 by 10, and so in the first line that should be filled is the 4th index. So if we look at these, they're all false, false, and now this one should have some true. And yeah, we do. We have true and then a couple true at the end. The bottom, should it be mostly true? Yep. And then the rest just has a couple lines. So I think so far so good. In fact, I'd love to just print off what this grid looks like. So we'll say for each, we're going to print the line of it. And we will just map the characters where if it's not filled, it'll be a period. If it is filled, it's a dollar, it's a pound sign. If it, then it will be this, else it will be this. Okay. And there we go. Okay. Yeah, so far so good. Then our logic will just have it starting here for the sand. So that's what we need to start simulating. In order to find whether the sand is going off and into the abyss, I think we just need to check if it ever hits the lowest position. Because like if there is no rock here, it would just fall straight down, and as soon as it hits the 10th y value, that's how we know that there's never going to be anything below to catch it. Same here, if it makes it, I think in the example, it comes all the way over to the left. By the time it hits this one and goes left, it would be at, well, it would be at -1 for x, but for y it would be 10. Okay, so for now, we need to simulate the falling sand. And what we can do is just probably have a loop where every time it finishes, if we end up with the sand at a resting point, then we will just go back again. Otherwise, we'll need to track something. We'll need a counter for how many times, because that's what we need to look at, right? Is how many grains of sand we're able to drop. Um, so we'll start a counter at 0. And then we'll just loop through and we can say while we'll need a flag for sand stopped. That can start as true. And if we ever get to the point where the sand wasn't able to stop, we'll just exit out of our loop. Otherwise, we'll keep going and incrementing our counter. So we will say, probably need to have a function where we update our grid with the simulation. So we can say sand stopped equals simulate sand. That could be a function. From that, that'll return a Boolean. And we will pass in our grid. Like this. Oh, we don't put it there, we put it here. Okay, add our parameter. So then what this will do is it'll take our grid and it will add a piece of sand at 500 minus the offset. So let's put that here. Starting x is an int, and we'll just pass in 500 minus our left offset. And then when we start simulating the sand, we will say grid x will be starting. Actually, we need the y. So grid, it'll start at 0, and then starting x for our second value. We will need to check at every point below that. So we'll need to create a sand position. And we will, instead of taking it from the grid, we'll just start it like this. Coordinate we'll make like this. And then we'll check the grid just sequentially and say if the grid, if the value down from y, so if grid sand position y +1 and sand position x, if that that should be a value in itself, right? This will be a Boolean. So if it is filled, below is filled, so we can't move down. So we'll want to flip these conditions. So we'll invert the if and say if it's not filled, then the sand position is going to just move down. So it's going to say y plus equal 1, and we need to make this mutable. So the x and y could be mutable because we could just change the coordinates as we go. So then here, what we'll need to do is just handle each other case. So can move down, and then we'll say else. We'll check if it can move left or right. So we'll say if it can move left, that would mean that y plus 1 in SAM position minus x. So we'll just do this, x minus 1, and then for the next one we'll do plus 1, because that'll be to the right, like this. Can move left and can move right. So then we'll do that, plus 1 in SAM position x. We're going to take 1 away. Same thing here, but we'll add 1. Like that. And otherwise, if none of those positions are taken, or if none of those positions are available, then we will say sand position. Yeah, then I guess we don't need to change the sand position. We would just set the grid, because this means it can no longer move, so now it's at rest. So we would say grid with our sand position y and our sand position x, where it is now true, it's now filled. So we'll need a loop in here where if at any point we're at the y value, that's the maximum, the bottom, we need to return false. So for here we can return true, the sand was able to settle, and we'll just keep looping through. So we would say really just while true. I think this can stay in our loop. We would say at the beginning of our check, if our sand position, if our sand position y equals rock bottom, we can call a value, which is the lowest point. Sand position is our rock bottom, and we can return false. Yeah, so that should be good so far. Our sand position is never actually changing. We're just updating the x and y for it. I think that logic is good. Let's see, here we just need to pass in the bottom now. Okay, and every time our sand has stopped successfully, we'll add another counter. So if sand stopped, then our counter is going to increment. Because if it ever can't stop, then we'll break out of our loop and we don't want to add to our list. So if we run this and return counter with the sample data, let's see what we get. The result should be, for this it should be 24. So let's run this. We got an error, out of bounds, -1. And that's, of course, saying that it cannot get to that point because that would be down here. It's trying to get -1. All right, so before we check if we can move down into the left, first we will just add another check that says if our grid X is at 0, if our sand position is at 0, which would be our X. If it's at 0 and it can't move down, then it's going to try to go left and it can't, so then we'll return false. And we'll do the same thing before we check right. So here, if it can't go left, then we just see if our X is at the very edge on the right, which would be, we would need to know that value as well. So starting X, we need to know our rock right, and we can pass that in here, which would be right minus our left, because that's going to be the offset. So rock right is going to be like this. We're at rock right, then we would also return false. Okay, now let's run that. Shouldn't get any more out of bounds. Okay, and there it is. There's our map printed, but it did not return any value from the counter. So I wonder why that is. So let's just take a look at each value here. So we start out with our sand position at 0, 6, then it moves to 7 and 8. And these are backwards. It should not be starting at 0, it should be starting at y0. So that's good. Good catch. Coordinate x should be starting x, and y should be 0. Okay, now we'll run it. Okay, 24. I think that was the correct answer from the example. Where did it say? Once all 24 units. Yep, so far so good. I'm going to put the puzzle input back in here. And let's see what we get. Gonna run it here. And that is a large map. So this is what we get, where it starts in all sorts of these places. Yeah, it looks kind of like a fun simulation if we were able to visualize it. So I'm gonna try returning that answer, 979, and we'll see how we did. Cool, that's the right answer. So let's move on to part 2. For this, you realize you misread the scan, of course. There isn't an endless void at the bottom of the scan. There's floor and you're standing on it. You don't have time to scan the floor, so assume the floor is an infinite horizontal line with a y-coordinate equal to 2 plus the highest y-coordinate of any point in your scan. So in the example above, the highest y-coordinate of any point is 9. And so the rock floor is at y11. Okay, and it goes on forever. Okay. With the added floor, the example now looks like this. So to find somewhere safe to stand, you'll need to simulate falling sand until a unit of sand comes to rest at 500, blocking the source entirely and stopping the flow of sand into the cave. So in this example, instead of the sand falling all the way down, it will eventually make this kind of structure. Great. This situation finally looks like this. Okay. Using your scan, simulate the falling sand until the source of the sand becomes blocked. And I think what that means is that we can't necessarily rely on 0 being the furthest left, because this can stretch on for infinity and always catch. So we'll need to modify part 2 to handle that case, because right now we're just checking those hard edges. Okay, so what I think I can do for this to change things up is instead of using fixed lists, because they would need to keep expanding to the left and right, maybe I can just use their actual value, and we will always have a bottom floor, so we're never like the sand is always going to find a spot to rest. So we don't have to handle the case where it's off of the index. So let's start with that. We can copy over most of the same for part one. We'll just handle the logic a little bit differently for that part of the loop. We're going to want to create it the same at the beginning, where we take, we're going to want to still add all the rock lines, still create our list, but we'll do the grid a little bit differently, I guess. We'll probably just need a list of all of our filled locations. So just a list of coordinates that are filled, and that will kind of start out as the rock lines. We don't need to know the edge locations anymore. We don't need to calculate offsets anymore because, yeah. Yeah, so let's just do that. Kind of remove some of this. We'll already have a flattened list. Um, already have a flattened list, and we don't need to do this part because this is just going through and setting them to true for certain areas, but we will already have the items that are true there. What we'll need to do is get, I guess we'll still need to get the bottom. Get the bottom area. So, yeah, let's redo some of this. The counter logic will still be the same, but in order to add the items for the floor, currently the only filled items will be the rock lines, and then, yeah, so maybe we still will need to get the left and the right. Rock lines. What is wrong? Oh, we need a val here. Rock lines, get edge locations. And that's just from a list of coordinates. So, yeah. This will tell us where we can start out with adding our floor points, but then we'll just need to dynamically add more floor points as we go. Or maybe not. Maybe we don't even need to include the floor lines, because when we're checking here, we can just always assume that if our y is this plus 2, like our bottom plus 2, so we should just need to check the bottom. Yeah, so for part 2, we can ignore left and right, like this. We'll still need to pass in, probably need a second version of simulate sand, so we can refactor this to be part 1, and then we'll create a copy of this for part 2. Get rid of that comment. Okay, so now we'll have part 2. We can collapse this. And this will only need the bottom position. And for sand position, we'll be starting at still a y of 0, but we'll always start it at 500. because these won't be offset anymore in part 2. Yeah, and so sand position, we're no longer going to be checking if it equals rock bottom. We're going to just be checking um, if sand position, it starts out here, but we need to see if it ends here as well. So if the sand position, if we are returning true, that means that it's settled. So if it can move down, yeah, in this case, we can probably remove these. So right now we have our cases where it can move down, it can move left, and it can move right. And so instead of passing a grid here, we're just going to pass filled locations, which will be a list of coordinates. And then instead of doing this for our grid, oh, we changed part 1. We want to change part 2. So we can change that back and say, instead of our grid here, have a list of positions, and now grid, instead of checking these, we'll just say if our filled locations contains a coordinate with those positions. So this will be our, we'll need to replace the X and Y positions. So X will come first now, like that. Yeah, we'll just do the same for each of these. So here it will be like this. X minus 1, I guess we could just copy that over and change them. Okay, like that. And here we'll say our sand position X plus 1. Okay. And so this means that none of the positions were filled in. And so we are going to actually make this a mutable list because we need to be able to add, and this is where we can check if our sand position, if our new sand position is still at 500, then let's see. Sand position, so every time we move down, yeah, so here we could just check if it still is 500. Sand position, X is 500 and our Y is 0. Then we will return false. Otherwise, let's return true. And in this case, we will just want to take our filled locations and add the sand position. Great. I think so far so good. Okay. So I'll try running this with our part 2, and that's going to just be a little different here. We're going to just pass our filled locations. Yeah. We need to also add some logic here um, if the bottom, because filled locations isn't going to contain this, so we need to first check if we're at the bottom. So if our sand position if our sand position y plus 1 equals rock bottom, okay, so we can remove this logic up here because we're no longer saying that when we're at the bottom that we're just going to fall forever. Now we're saying if our next position down is rock bottom, then we are going to just add our current sand position. What we need to add, we're going to add our current sand position and return true here. Else we'll just check the rest of the cases because we don't actually have filled locations with the floor, so this is just checking that floor. Yeah, so now for our logic up here, we just need to update. We only need to pass in the rock bottom, so we can take the rest of these, get rid of them, and that is actually going to be our bottom plus 2. And for filled locations, that's going to be rock lines, because that's what it starts with, and it will just get updated from there to mutable list. Okay, I think so far so good. Let's run it with the sample text again and see what we get. Part 1 should stay the same. Part 2 is just going to keep running. I'm going to set a breakpoint in here and just see. It should have stopped really soon. Okay, we're going to skip part 1 because we already know that works. Now for part 2, let's look at our filled locations. Our filled locations, yeah, it should be 15 for 1 rock line plus 5. So every time we finish this, it should go up by 1, but it's not. Oh yeah, that's right, because it's falling down. So if we're at this, I think what it's showing here is that we might still be filling our positions. No, that seems right. We should be able to, yeah, we got down. We just didn't add a sand position, a filled location. We should have added it. Oh, and that's right. That's because we're creating a new list up here every time we repeat. So every time, because I made a mutable list here, so it's creating a new list, and then when it repeats, it just passes in the old one. So it needs to be a mutable list before we get here. Yeah, like that. Okay, now if I run it, it should update. Yeah, 92 was the answer. What was it in this case? 93. So I was one off, and I think that's because I'm not counting if I return false. So in part 2 in my loop, I only check if it's true. But I think I should just always count because I always know that if I add a piece of sand, it's going to stop at some point. So now if I run this, I should get 93 for part 2. Yeah. Okay, so let's put the real input back in and run this. It could take a minute for part 2. Okay, that's stalling it looks like. So I'm gonna add some printing and just see if it's making progress or if it's getting stuck. Maybe brute forcing this isn't possible with how much calculations there are. So let's take a look and see for part 2. I would like to print similarly for part 1. I want to print this kind of at each step and just see what it looks like. So after every step, I'm going to do this. I'm just going to print the size of rock lines. Yeah, rock lines. See how much it's going up by. It turns out you can fit a lot of grains of sand in a cave. Well, I'm gonna step away and see if this finishes. Cool, after about 3 minutes it completed, so not the most efficient solution I've come up with. But here's the answer it looks like, so I'm gonna go ahead and try that. Great, yeah, it worked. So, fast enough computer and you can accomplish really anything. Okay, so that's enough for today. Thanks for watching, and I'll be back tomorrow with a new video.